Okay, so in this example, we have a small component in an electronic device has two small holes where another tiny part is fitted. In the manufacturing process, the average distance between the two holes must be tightly controlled at 0.02 millimeters, else many units would be defective and wasted. Many times throughout the day, quality control engineers take a small sample of the components from the production line, measure the distance between the two holes, and make adjustments if needed. Suppose at one time 4 units are taken and the distances are measured as the 4 measurements we have there. Determine at the 1% level of significance if there is sufficient evidence in the sample to conclude that an adjustment is needed. Assume the distances of interest are normally distributed. Okay, so let's start. Again, just as before, we don't know the mean of the sample and the standard deviation. So if you take these 4 and you put them into your calculator, the sample mean ends up being 0.02075, and the standard deviation, S, ends up being 0.001707825. All right, so let's now set up our hypotheses. Okay, so everything is good if mu is 0.02 millimeters, but we're looking at the possibility that it's anything but that. So we want as our alternative not equal to, because of course if these holes are too close to one another, we're going to have a problem, and if they're too far away, we're going to have a problem. So not equal to is the alternative. All right, now let's do our test statistic. Now again, we do not have the population standard deviation, so we're going to have to use our t. And so we'll have our sample mean minus the mean that we've got in our null hypothesis divided by our standard deviation 0.001707825 divided by the square root of our sample size, which is the square root of 4 here. So I'm just going to go ahead and write 2 there because we know that square root. And now we need to do this calculation. And when you put this into your calculator, you get 0.88 if we round it off to 2 decimal places. Now we can pretty much guess that this is not going to fall in our critical area. However, let's go ahead and do our calculation for practice. All right, so we're looking at a significance level of 1%. All right. Remember, though, with a two-tailed test, we have to divide this by 2. So when we get ready to look this on our t-chart, it is 0.005 we want to put in. And then since we have 4 in our sample space, our degrees of freedom are 3. All right, so I'm going to go and again use that little application for StatTrek. And degrees of freedom are now 3. And we want the probability to be 0.005. And I have to erase this, otherwise we can't get our score. So if we calculate, that score is negative 5.911. And of course, since it's a two-tailed test, really it's both positive and negative. Positive and negative 911. All right, now remember, if it's two-tailed, we need to have values right here for our test statistic that are either less than negative 5.911 or greater than positive 5.911, and obviously 0.88 is not. So we fail to reject the null hypothesis. There is not enough evidence to reject the null hypothesis. It appears that the machine is still correctly calibrated.